Hello everyone, we are back with, I don't know how long this API review will be. This might be the full 2 hours. At least that's what Brandon told me. So let's see. I think I have the right issue open, but if I'm not. Why do you want to talk us through it?
Headers, cookies, IP addresses, all that fun stuff. So you can have a rate limiter on the HB context that will maybe do a concurrency limiter for based on the IP, or a token bucket limiter based on some cookie or something. And so that's the general premise. What's more complicated is after the general shape of the generic rate limiter, and it's a pattern for building a generic rate limiter, which I've put in the proposal below. And it's, I think, going to be the more complicated thing that we discuss in this meeting. And it basically, in my opinion, it's hard to build one of these generic rate limiters. So we wanted to provide a way to make it easier, so that you don't have to deal with all the complexities of building one of these. Yeah, any initial questions?
So I see you called out the chain limiter API.
Oh,
you
yeah.
mentioned that at all? Okay.
That's I briefly mentioned that in the sentence below in the proposal, but yeah, we can. I don't know if we should talk about that right now or later.
My general question is like, so we shipped the non-generic one already.
In 7.0, it's starting to ship. Yes.
We shipped only a preview beforehand.
Yeah, we've shipped a single preview of it so far.
And then, is it fair to say the shape is identical to the non-generic one, except for when generics are appropriate, or are there differences in?
This is the exact same except for T resource.
So same default, same default values.
Yep. I guess it's slightly worth mentioning the dispose stuff here technically hasn't gone through API review. That's what the other tab you have open is. So we can either like ignore that or discuss it.
I mean, that looks like the correct pattern for a async disposable.
Sure. It's just, I think the initial API review for the rate limiters didn't have iDisposable. So we did add it as part of the initial commits, but we opened an issue to review it later.
I mean, do we have any opinions on configure await, or is that's independent of the pattern?
I believe that is the line of code that Steve told me to write in the book.
Yeah, this was copied from some of the docs somewhere. And I believe if it's a library that will run anywhere, it should have configure await, right?
Yeah, because it's not a UI thing that needs to get back to the UI thread, so configure await false is correct.
So basically, this has all the same methods as rate limiter, but with a new first argument, which is the T resource ID.
Yeah.
The main alternative that I could think of is something similar to like Microsoft extensions logging, right? Where you basically would get a rate limiter, right? You could call it like get rate limiter or resource ID.
Oh, like get logger, yeah.
Potentially. And I know that we've discussed this already, but so like what was the reasoning for the trade-off? Was it like perf or ease of implementation or something else?
So get rate limiter of a T resource basically is what you're saying.
Basically, yeah.
Yeah, I mean, it's something, but
By the way, I'm sorry, I'm not really wasn't meant to be that difficult of a question. Like I think the reason that was brought up before is performance, right? Like there would probably be extra pooling or allocations or something along those lines.
yeah, it would make the lifetime of the rate limiter less known to us because we'd be giving you the rate limiter. So we couldn't do some things that are going to be called out later in the stock for the builder pattern. Also, the consumption where you couldn't like have a rate limiter. Well, no, you could actually. I think it's mostly just ownership.
But that's independent of the genericness.
Yes. So, it's weird to talk about ownership because we haven't looked at the builder and the proposed stuff with that. But basically, with the builder pattern, we'd be creating a generic rate limiter for you that would basically own the rate limiters internally. And we would want some way to probably clean up references to those if they're not being used. But if we're just giving people a rate limiter, there would be no way to know when that rate limiter is in use or not. Well, there would be a way, but there wouldn't be a way to know if they cached it in themselves or something.
Right.
And expect it to still be usable in the future.
Yeah, this may not be the right forum, but if we haven't actually shipped the other rate limiters yet, has anyone been paying attention to feedback that the fact that the call to acquire always succeeds, but then you're supposed to check a property on the returned value to find out whether or not it failed is bad for usability?
There's been at least one comment on the original rate limiter API proposal issue around something like that, where we return a rate limit lease and they were saying we should be returning a rate limit acquisition instead or something that has slightly different properties because it makes more sense, like I think you're saying.
I know that I've seen somewhere somebody comment on the fact that like you call it and it succeeds, and most people, unless they read the docs, are likely to say, "Oh, I called acquire, it didn't grow or do anything else bad. It probably worked." And it's like, well, now you're doing all the work of having a rate limiter without actually having a rate limiter because you didn't check for, I called acquire and it returned, sorry, I couldn't do that, and then your code moves on because you didn't check that. So. Yeah, the only reason I ask is if we haven't shipped anything and we're basing this on a thing we want to change, I guess we would make them be the same, so it probably doesn't matter. But
right, I mean, the whole like this API is cooperative, so like no matter what we return, you probably have to check something unless we're throwing. Right.
Indeed.
So, I mean, maybe you want to review this in part of the dispose, but who's calling dispose? Is it the user, or is that part of the rate limiting API?
The user would be calling dispose when they're done.
That makes
So
sense.
generally, yeah, we would be calling dispose in the builder stuff later for you, but that's not related, I think, to your question directly.
I mean, that's the only concern
So-
when it comes to pooling, right? Because if you add the notion of ownership and dispose, you don't want to be in a world where people have to, know when they can safely reuse objects versus when they're supposed to, like, call some other method that, magically revives them after dispose. Only a bad. Dispose should usually mean the object is not. So
Right.
if you're pooling it, that means your pooled object is not dead.
Yeah. So the pooling would be an internal thing for us, and so the user wouldn't get like direct access to the rate limiters that we're using.
So, okay, just to clarify for some people, rate limit lease is disposable for refresher. So that would be disposed by the user when they're done with like the operation for like concurrency limiters or whatever. And maybe we should get to the builder, because like I don't know if everyone else realizes like what you're talking about, like by what's getting disposed internally.
Sure.
Yeah, I guess that is the question, like, what is the thing that's being pooled? If the limiter itself is not the thing that's being pooled, if something else is being pooled, then yeah, it doesn't matter that the limiter is. I was under the impression
yeah,
that
so
you talked about the limiter.
yeah, sorry. The generic rate limiter, the disposal here, that's owned by the user, and we're fine with that. It's the internal implementation of the rate limiter that we're thinking about. That would be pooling individual non-generic rate limiters for use, and it would own those.
So a typical app creates, or a component creates, a single generic rate limiter instance and holds on to it for pretty much the lifetime of the component or the application, right?
Right. So like you can imagine in ASP.NET Core, you'd have a middleware that just owns a single one of these, and it rate limits all HTTP requests. And that would be for the lifetime of the entire application.
So in probably the most common case, dispose actually is never going to get called. The app's just going to end.
Sure.
So what happens then with multiple requests? Is the idea that every request processor basically has its own, or is the expectation that the instance is shared and basically multiple threads might call acquire?
Yes, the second one.
So effectively, the assumption is that all the stuff has to be there.
Yep. Well, wait async would have to be thread safe because it queues.
Yeah.
And in general, this is true for the non-generic rate limiters as
Right.
well, right? Like they're thread safe.
Yep.
And so this is abstract. So what is the thing that people are actually instantiating? They derive their own type from it? Derive
You
type.
got to show them the builder.
Yeah, so I mean, without a builder, they'd have to write their own thing. But with the builder that's listed below, we would basically provide a common way, an easy way for them to write it. You can ignore that if you want. That's just some sample code of what someone might write. But
would actually use.
This is the thing we think people could use to write, basically compose a generic rate limiter. And you can basically say, I want my resource, HB context, to look at a header and use this rate limiter for these sets of headers or specific header. It can use a token bucket for these IPs. It could use et cetera, with different policies.
Is there a
so
reason?
This internally, oh, sorry.
So I was just going to say, is there a reason, before we get into the details, that this sort of wither builder for building up these limiters is relevant to the ones that are generic with a resource, but aren't for the ones without a resource?
Sorry.
Like we already have a rate limiter that's non-generic, right?
Right.
There's no builder for it, correct?
Right. There's concrete
Why the
implementations for
discrepancy?
them. Sorry?
Why the discrepancy? That's my question.
Well, so those ones are like fairly simple, I would say, to implement, and like there's very obvious implementations for those. So we already have 4 that we're going to be shipping. The generic rate limiter, it's a lot more complex, I'd say, for a user to actually implement one of these. It has very
I mean, certainly, I understand the complexity when it comes to being able to, basically under the covers partition based on the resource. But I would have expected that with policy, with concurrency policy, with token, or maybe not with token bucket policy, but with no policy, with default rate limiter, like all of those, aren't those also applicable when it's not partitioned? Or they're only relevant when there's a key?
Well, so like the reason you wouldn't have well, so you could use these in, how do I explain this? In a usage with the non-generic ones, like it seems like you would have a single rate limiter for some thing that some resource. Like you wouldn't be doing this for a T resource type scenario. I don't know if I'm saying this right at all. Like,
can we scroll down to the sample usage?
Sure, that might help.
But
at the very bottom right here, yeah.
But the idea is that, like, just given the options, normal rate limiters are like easy to build, right? Like if you don't have a T resource, right, and you want a concurrency limit, like there's one concurrency limit for all people trying to acquire all callers, right?
Right.
Like there's one concurrency limit. This is like encoding business logic, which you could
write with the non-generic, but it'd be a bit of a nightmare to maintain, I'd say. This makes it a lot easier.
I guess, for example, in this code sample here, forget about that first .with token bucket policy line for a moment.
Mm-hmm.
The other 2 lines are just as relevant. Like a with policy that specifies a queue processing order and a concurrency limiter options that specifies oldest first. Like those are both relevant for a single bucket, right? So they're both relevant for the non-generic case as well. The only line here that's not really relevant for the non-generic case is the with token bucket policy, since that's specific to buckets. Is that a fair statement, or am I totally missing the mark?
I don't know what you mean by relevant to.
So one thing I would clarify is, so like the queue processing order newest first, like that's already been API approved. That is the non-generic API. So this is creating, basically, it's saying for requests with a cookie header, we want a concurrency limit using an existing non-generic rate limiter. So like the new concurrency limiter, that's the already approved API, basically.
All right, I'll forgo this until we've had more discussion about it. I'm just trying to understand. It seems like we're proposing this whole builder scheme for the generic when it would still be relevant, when 90% of it would still be relevant for the non-generic. And I'm trying to understand why. But we can come back to that.
And my question,
yeah.
I see.
I guess my question is similar to, like, how does, I mean, zooming off from the builder for a second, how do people choose between rate limit and rate limit? Why would I use one over the other?
Well, so the normal rate limiter is non-generic. Like they're perfectly fine to use and everything, but they're limited to, you want this rate limiter for everything. if you want multiple rate limiters, you then have to start writing, if statements, dictionaries, all this kind of storage. And then you have to write your own, key parsing, or not parsing, but grouping system. And at that point, like it seems like you just want a generic rate limiter that already does that for you. And the generic rate limiter is built on top of all of those non-generic ones. Like internally, it's just going to use them. So it's just like an extension, basically, of the non-generic rate limiters.
But that seems similar to what Steven said. That seems kind of orthogonal, though, right? Like what you're talking about is more like the aggregation of multiple different kinds, right? Versus generic versus non-generic is more the API share. But object, or do you deal with some specific T resource?
Right.
That's kind of why I mean, another way to look at it is by saying, the rate limiter was a mistake. We really wanted only the generic rate limiter. Kind of sounds like what you're saying, at least from the user standpoint. Say the non-generic rate limiter is just, a building block in our implementation that is probably not used by anybody. Is that your statement, or?
I mean, that's a way to look at it, but I don't think it's right, because like there's very valid cases for using the non-generic rate limiter where you don't need to do it based on keys, like.
And then for those, you would not use the builder then either, right?
Right.
So like, talk real concretely, right? Like, say ASP.NET, right? Like, and we plans to add like a rate limiting middleware. If all you want is like an absolute rate limit for every request, we might allow you to specify a non-generic rate limiter, right? So it's like this service, for whatever reason, has a max rate of like 100 requests per second or whatever. You could do that with the non-generic rate limit, right? But if you want to make it different per user, like the user ID, right? Like your iPrincipal could end up being like the T resource ID. And then this is showing you a more complicated example where you have like different kinds of non-generic rate limiters for different kinds of resources. But it could just be like all token bucket rate limiters, just with different rate limits for authenticated users versus anonymous users or something like that.
You see, what confuses me is that there seems to be no API relationship between the generic and the non-generic. Usually when you look at how our types relate, it's either the generic one is effectively a convenience wrapper over the non-generic one and it just does the casting for you, or we have the other way around where the non-generic one is basically just derived from the generic one that passes an object effectively. But it seems like in your world they're like completely separate things. They just happen to have a very similar API surface. I guess that makes it hard for me to reason about how you would use that. So for example, I assume the rate limited handler, for example, in the constructor would not take the rate limiter. It would take a generic rate limiter of HTTP request message. Which means I don't understand how you can have a generic rate limiter. I mean, that's that phrase here, like the non-generic rate limiter as the universal rate limit on everything, when effectively all the components that do something very specific are effectively always just limited to take a generic rate limiter of whatever resource they provide. That's why I don't understand how they relate.
See.
Maybe we should call it a partitioned rate limiter. But anyway, yeah, I see your point. That like certainly the partitioned rate limiter, or the generic rate limiter, is strictly more capable than the rate limiter that's already been approved. Like this adds basically partitioning on top of it. Like it adds an extra piece of functionality there. So
yeah,
like if you don't want partitioning, you can have like a single key. But yeah, sorry.
Yeah, which seems to be completely I mean, another question I had is like, why do we call it generic rate limiter? Why don't we call it rate limiter of T, which seems more in line? But like, I think in your
Yeah,
case,
that makes more sense.
because it's really not that, right? Because the normal rate limiter doesn't take a resource, right? The resource is either ambient or, you know, there's no, it's not an argument to acquire, right? Versus in here, it is part of the design that you pass it in, right? And so the difference really isn't generic versus non-generic. It's really it's a different thing. It just happens to share the name a little.
Yeah, this is the confusion. So I'm reading your message, Tobe, and for the YouTube viewers, I'll kind of say it. So it's like if I want to build a non-generic rate limiter, right? Like the API that's already approved, like why don't we do something where it's like with policy concurrency limiter options, and then add another concurrency policy, and then basically. And this is why I asked Brennan if you want to discuss the chain rate limiter thing, because I think that is what this is basically suggesting. It's like even without a T resource, I might want to compose multiple rate limiters basically in a sequence. So you have to acquire each one.
And that's my question: is this the API sample is suggesting that we're going to be chaining these things together. We're adding multiple policies of various kinds to build up one resulting thing based on the input key, effectively. And it's being determined by delegates that are passed. And the result of the delegate invocation is the thing to be applied in that chain. So in a non-generic world, you don't need those delegates, but presumably you would still need the same chain. And I'm wondering, why is the chain only relevant in the generic world and not in the non-generic world?
Yeah, so the builder isn't actually chaining.
It's not?
No.
What is it doing?
So it's applying individual policies for
presumably
the key.
with policy with concurrency policy, I might apply policies to the same partition, right?
Explain how null works, please.
Right, yeah. So you return null when you don't want a policy to apply. So you don't use that. You move on to the next one. So yeah, this thing with token bucket policy in this example.
This short circuits the whole wither thing? Like only execute the with concurrency policy if the with policy returned null?
Right.
Wow.
Yeah, that is not intuitive.
So
that is super confusing.
The original name for this was aggregate rate limiter, but we realized like aggregate is super overloaded. Like you could apply it in 3 different ways and have 3 completely different interpretations. So we were trying to move away from aggregate and support all 3 basically different variants. And that's why we added a chain, like a create chained generic rate limiter method that would then allow you to chain the policies like we're saying.
But if
I could definitely see those.
If this isn't actually chaining, why do I have different with methods at all? Why isn't it just for this key, use the following options? Done.
Right.
And if there's a chain, if there's an if then else cascade, that happens within the delegate.
But it doesn't seem to be conditioned on the key, right? It's an arbitrary condition over there.
It is. It's conditioned on the oh, wait.
Yeah, I mean, the first one basically says if it's a post, then do that. And the second one says, well, if you have that particular header, do it, right? That suggests that it's part of the key.
Oh. The key is HTTP request method, so or message, not method.
Yeah.
Let me try again. You've got 3 calls here, 3 different with calls here, each of which is taking a delegate that either returns something or returns null.
Right.
And you only go on to process the delegate supplied to the subsequent .with if it returned null.
Right.
Why is that not just user logic inside of a single delegate call?
Like you mean they have if post, else if cookie, else
yes.
URI. Yeah. So the reason is because it's probably I think it's a little more complicated than that. You can have what can you have? I know I have concrete examples somewhere. If you had a post request, well, no, that's true.
To be honest,
because
I don't.
a different but reinforcing Steve's, why isn't there just a single delegate, or you have a thing that just has a single abstract that you implement? Like if I call add token bucket policy, sorry, with token bucket policy twice, is that replacing or is that overwriting? And how does the order, if it's with token bucket policy, with policy, and with concurrency policy, and then with token bucket policy again, what does this thing even look like?
Well,
Versus if it's a single delegate and it's like you just look at the code and you can see what's happening.
Sure. I mean, none of these replace, but
So as far as I understand, right, like these predicates, right, go from T resource ID to basically a partition, right? And they're run in order.
Yeah, partition key. Yep.
Right. So these predicates, and then like the T partition key or T key could be null, and if it's null, you'd fall through to the next one. So you don't basically fall through until you get a null result from one of these predicates. Otherwise, you just pick the first thing. And I think kind of the scenario we were looking at is like, you know, at first you might want to partition between like authenticated and like non-authenticated users, and then you know, after you partitioned out, say, all the non-authenticated users, you might want the key to be like the principal name. Could this be done with like a combined key or something, and then just basically have a single predicate and basically don't allow this like predicate fall through logic? Would that simplify things? I think those are all interesting questions. But
I mean, the thing that I'm
describes...
the thing that all of my questions are getting at, and if I'm taking us off track, I apologize. We can park it for a little while if that helps. But it fundamentally, in my mind, my mental model is the difference between the generic and the non-generic is purely that the generic takes in some key and effectively tells you which non-generic instance to use. That's my mental model. And so there's one translation step. There's one, here's the key, give me the non-generic thing. So the idea of supplying a bazillion different callbacks, each with delegates with different withers, to do that one translation seems really inconsistent with the idea of I either have something that maps from A to B or I have a B. And here we're saying I have multiple things that map from an A to B and they somehow fall through from one to the other. And that fall through logic is relevant in this generic case, but somehow we don't need any of that in the non-generic because, you know, we just have the instance. So that it just seems super complex for something that is really just one single func. Here's a key, give me the thing to use. I guess I'm struggling to understand why it has to be this complex.
Yeah, or if you need, it's a single func or one func of here's the T, it goes to a string. And then the second one is, hey, something's asked for this string and I don't have a thing in that bucket. Give me a thing to create for it. You're the one who gave me the string. You should know what to do with it. So func of T resource to string and func of string to whatever the base class of the rate limiters is.
I see. So only like a single one, not all these other ones.
Right. You return.
That's my feedback / question is, what benefit is all of these different withers and null fallback policy providing that the user couldn't just achieve with their own if-else?
So
Okay, I see.
Oh, sorry.
No, continue.
Yeah, so one thing that we were considering when discussing what is now called the generic rate limiter is if we have a function that just takes, like, say, the T resource, so let's say in this case it's in ASP.NET HTTP context, and then returns the rate limiter instance. Like, let's say that I wanted to have a rate limiter per logged in user, right? I want to make sure that I'm reusing the same token bucket as instance, right? Every time that same user makes a new request. So one of the things that's tricky is basically managing the lifetimes of all these rate limiters. So if I just had a function that took like an HTTP context and returned a rate limiter, I would have to make sure to return the same token bucket instance every time, right?
It doesn't have to actually return. I mean, that was my mental model, is it returns the rate limiter instance, but in this example, it's returning presumably a key, right? All three delegates are returning a key. That's a string. It could do the same thing. The func could be from T request to string. That's fine. And then internally we map string to the rate limiter instance to use under the covers, which is presumably what the thing on the screen is also doing. If my feedback isn't the func needs to be from T request to rate limiter, it's that I don't understand why it's not from a single func from T request to something, rather than an arbitrary number of these withers that has a fallback on null falling through from one to the other, managed by this sort of framework of the builder. Why isn't it just new generic rate limiter that takes a func?
Two funcs.
Sure, two funcs. I assume func for lookup and one for build or something.
Right.
Yeah, I think we're on the same page there.
Yeah, I didn't understand the original time, but yeah, that makes sense.
I think the fall through stuff is a little bit more flexible. But
That's
yeah,
what
I
I was
definitely
thinking,
see.
yeah.
But I do see why it can be more confusing as well.
Can you explain the flexibility? Is there something you can do with it that you can't do with the other approach, or you think it's just easier to express certain scenarios?
The latter, in my opinion. I think with a single func, you could do all the things. Or sorry, without the fallback logic, you'd still have the T generation and the two funcs. But yeah, I think you could do the same thing with the fallback.
I think developers, and I could be wrong, but I think developers are used to writing C# if-else statements, and we're basically using function calls to introduce our own conditional flow control. I don't know why we would do that when we can just use C#.
I think it comes down to, like, if you require everything to be set up with like a single with call or whatever, though it probably would be called something else if there could only be one, you would have to be more thoughtful on your key function, not to create like too many partitions, basically. But
can you elaborate how that's different from
possible?
Can you help me understand that better? So with what's on the screen, how does this prevent me from creating too many versus my own if-else, that if request method equals return HTTP method post, else if try get value cookie, return cookie, else whatever? Like, how does one versus the other help me avoid creating too large a string space?
Right. So imagine that if the user's anonymous, right? Like, I want to do something, and then if they're like logged in, I want to perhaps look at the request path, right? Like, the obvious thing for the key generation function, say I'm generating a string, would be like to concatenate like the user ID and then like the path of the request. But like, if I'm always gonna just like throw someone in one bucket if they're anonymous, regardless of the path, like, I don't want to create a new partition for every path. Some of my like key generation function, I'll just have to make sure to always return the same key for the anonymous function. For the anonymous user.
Is that somehow addressed by the APIs that are currently being proposed?
Basically, the first with policy could be checking like the HTTP context.user.
But that's the same as writing if, whatever, if I'm anonymous, return anonymous. Like, done. That's, and you can look at it, you can reason about it.
Yeah, if they both have to do the check, I'm curious. I'm not understanding why one is easier or more error prone than the other.
So I know one benefit that's not related to that really is that we can return any key here, not just string. So we can optimize for like struct versus object.
Sure.
That's something you can't get with if else.
You're saying because you might write dot with func that returns T1, dot with func that returns T2, dot with func that returns T3?
Well, like here, I'm returning a post, which needs to be a method. It's not a string, right? And then the cookie, that's a string because we just made it a string. But the other one is a HTTP request path or whatever that type is. Like they're all different types that we're returning for the key. Whereas with the if else delegate, we'd have to return always a string, which requires an allocation every time. Well, not every time.
So
yes,
I mean, you would cache a POST string, but
presumably this is behind, or this is being implemented with a dictionary somewhere. Like, is it each one of these has its own dictionary of return type to?
Right now, yes, which is how we're doing the different key types.
Because again, like, one can do that with object. Like if you get to control what your partition key type is, so you have your resource type and your key type, like you could do that with object, or you can, make your own pseudo union or whatever. But like, so yeah, we don't have to say string. We can make it be a user choosable T at the type. But yeah, it still doesn't. Even saying the type doesn't have to be the same across these, I still don't see why it's not just one. Write your partitioning routine, and then internally it handles. You partitioned to a thing that is not a valid partition. What would you like to do here now? Sorry, not an existing partition. So that would be the great. You returned post. What do you want to do about post? And then now you say, oh, make a new token rate limiter.
I'm also curious, some of these things are returning null, and null is being used as a sentinel to say, ignore the value, go on to the next one. What does that mean if you were returning an arbitrary struct? Do you have to return a nullable of T? Is that?
Yeah, so yes.
So partition on int means
with method has to return either a reference type or a nullable struct.
I think so.
Because if your key was int, there's no way you can hit the next one.
Right.
Or be terminal, I suppose.
That design also means, and this might be a fine decision, that null is always an invalid value.
That would be something we'd have to say, yeah, which is not obvious. Well, except for doc comments, but yeah.
Because everyone reads doc comments.
My top level feedback, and again, take it with a large grain of salt, but the design was very non-obvious to me. So
that it wasn't fallback, or that it wasn't chained.
That it wasn't chained. And why I would care having a separate builder for the generic when I don't have one for the non-generic, which is addressed if you just take funcs to the generics constructor. So for me, I would err on the side of simplicity, and try and just, what is the bare bones minimum we can get away with? But if there's valid reason, it would be great to understand, what we gain for the complexity.
Yeah, so your general thing would be a concrete rate limiter type that has 2 delegate methods in the constructor. That would just handle.
I would have looked at that design and said, oh, I get what this is doing.
Right.
I think that's pretty. I mean, it makes sense to me. I feel like maybe we can come back to that. And is there other things we can discuss? Or are there?
Yeah, there are. There's the 2 new methods / interfaces that we think are somewhat necessary to make the rate limiter of T implementation more efficient as regards to timers and memory cleanup. So basically, internally, this thing will be storing, dictionary of key to rate limiter. And in order to not have that just grow indefinitely, we'd want to clean up rate limiters whenever we can. And in order to do that, we kind of need to know that a rate limiter is not in use. And today, we could do things like look at if it's a concurrency limiter and say, oh, if it has all of its, permit counts, then it's not in use, so we could clean it up. But that's not a generic enough solution for like any type of rate limiter. So the idea is that I think if you scroll up slightly, we would add an idle since property to rate limiters, so then we can look and see if the rate limiter is actually idle and clean it up from the internal dictionary to save memory. And then, well, we can stop with that one, but.
I mean, why couldn't you just have a very simple method that is, apply when, where the first argument is a condition, the second one is the rate limiter?
Could you describe that slightly more?
So right now you have with policy and you have with token bucket policy, for example, right? Instead of doing that, you could just have one method that just says, instead of projecting to a key, just take a func that returns a bool, and then has another one that basically returns you a rate limiter. So basically, if the person wants to do concurrency limiting, well, they construct a concurrency rate. They do something else, they token bucket rate limiting, well, they apply that limit. But you don't have to do this null stuff. You just basically return a predicate.
I'm struggling to see how that helps with the idle stuff.
No, I mean it just simplifies the overall design, right? I think the idle stuff I think is almost orthogonal to that, but like I still struggle with like, why do we have so many different, I guess, lines you can construct stuff, and then reasoning about how they are funneled.
I think I understand the question, and it kind of ties into the idle stuff, and it's what Steve was talking about earlier, which is, sorry, Tobe, but so the big thing is we want to reuse the rate limiter instances internally that you're returning from these methods, right? So you suggested 2 funcs, right? One that is like an actual predicate, right? That's just true or false. Like I want it to apply to this or not, and then the other one would return the rate limiter. Is that the suggestion, Emo?
Yes.
So the thing that we want to do is, so say that we have a token bucket rate limiter. So say we have like a max rate per user. We want to make sure for like the second request coming in that internally we're using the same non-generic rate limiter for the same user. So we need like a comparable key. So we were talking about it being a string or potentially like any, like right here, right? It's I think we're calling it T key, and presumably it would be like I comparable, and that's why like we're basically don't want to construct a new rate limiter instance every time, nor do we want to require the user to maintain like their own dictionaries to like give it like we want to manage the lifetime of like the non-generic rate limiters ourselves because it's hard to do. Does that make sense?
Yeah, I guess, yeah, I only looked at the first two where you basically return a fixed string, but then the last one, you basically have a request URI, or you could return the IP or whatever else you want for bucketizing.
Just random question. You mentioned you want to maintain the lifetimes yourself. What dictates the lifetime? Like, if my key is, as in the first case here, HTTP method.post, like when does that limiter usable?
Right. That's what the idle since proposal is for.
I see.
Because yeah, we have no idea of knowing if the rate limiter is in use, if it's not in use, if it's you can GC it effectively.
I guess for post, it's probably fine to say like it's probably the lifetime of the app, but if it's for request URI, well, if nobody hits that URI in like 6 hours, then you would say, right, okay, now we get limiter.
That I guess if these methods, I think you could give it a what do you call it? Some lifetime parameter. You could do that. Otherwise, we'd have to rely on some property that the rate limiters had.
Sorry, I'm still. You may have already said it. I just missed it. I had to step away for a second. I still don't understand. We're providing the built-in rate limiter implementations, right? We expect our rate limiters are going to be the 99.999% use case.
Sure.
For HTTP method.post as a key, when is idle going to be true?
That would, well, the idea would be once there's no one that is currently consuming the concurrent, or I guess the token, once the token bucket rate limiter has all of its tokens refreshed, it would be idle.
All of its tokens refreshed.
Yeah, so internally it just, it increments tokens on a set interval. And if there's no queued acquire requests, and if all the tokens have been replenished, then that means no one is currently using it, and it's at its max capacity. Or what's the opposite of capacity? But yeah.
I see. This doesn't. Okay. I guess that I'm not clear how. I mean, there are race conditions here that abound. The moment is idle gave back an answer. It could be wrong.
Sure. So that would be that is a valid thing, but internally we'd be locking, so like we can know that it's not used, but I could see if you want to more
really.
generics. Why not?
I mean, it depends on when you're running your cleanup loop. And
sure.
And so I mean, I guess maybe you could be entirely bound by that, but if you've returned the instance back to someone, you don't know if they still have a live reference to it.
That's why we're not returning instances of rate limiters.
You've returned something that they can call acquire on.
We've returned the rate limit lease.
At some point you have to give them the thing that they can put in the statement that says, I now have enough context, please go try and acquire the lock. Or the resource limiter lease.
They have access to the generic rate limiter, and they call acquire on that. And that internally will call the non-generic rate limiter APIs. So
okay.
if
that's locked, then yes, you can do that. They still can have a indirect reference to the thing depending on how your lease is handling the release
sure.
operation. But as long as all of the things end up handling dispose gracefully, then I guess that works.
But they only have access to the outer rate limiter, right? They don't have access to the actual token bucket rate limiter.
Right,
now.
but he was saying like we return a lease to them, which will have internally probably access to the rate limiter, but that should be safe from the user's consumption perspective.
Right. So in that sense,
Like the only hypothetical. Oh, sorry.
Sorry. So in that sense, it is safe because the implementation or the wiring of that could make sure that you have the locks in the right place.
Right.
The user can only ever interact with the outer one.
Yep.
Yeah, the only evil thing I could see is like someone stowing away a reference from the rate limiter they return from the.
Yes.
But like, yeah, other than that, we control all the access.
You mean from the withers?
Yeah, which you hope no one would do. Like, we would
Wow.
tell no one to do that.
I think if
Like,
you do that,
literally-
then
Yeah.
you're deliberately doing something that seems fairly obvious in the design. You're not supposed to argue. Yeah. Like it would be a bit more problematic if, let's say, the lease has a property of type rate limiter, and I can walk up, because then
Right.
that is not necessarily obvious that you're not supposed to.
I think I'm still missing a key piece of how things connect together. If for the generic rate limiter case, these rate limiters are all hit internally, right? The whole point of it is to hide them because you may not even want to use concrete rate limiter instances. You want to do something lighter weight, is what I've heard. Is that right? Who is looking at these idle properties for the in the generic case? No one would ever be looking at these idle members other than it's an internal implementation detail.
Right.
Right. So the only place you would be looking at these would be for the non-generic. If I created a non-generic instance, these properties would be for me to use. At that point, I can't take the same lock that was being used internally.
Yeah.
So how was this useful to me?
It's at least useful in the sense that you don't have to replicate the logic that determines whether the rate limiter is idle or not.
But I don't. The moment I check whether it's idle, it could no longer be idle.
If you knew up a non-generic rate limiter and you do the same thing that our generic rate limiter that's built on the non-generic ones does, like you can
Your
say,
generic one is taking the same lock.
I don't think we'd be sharing rate limiters though. Like you'd either be in one world, like
No,
we own.
Okay.
Sorry.
I guess I'm not understanding. I thought that Ren was saying that the reason you could ensure consistency was because a single lock would be acquired both by the individual rate limiter per key instance and by the outer controller determining whether it could clean up that rate limiter.
Not quite. Basically,
if that's not the case, then if the outer rate limiter checks the inner rate limiters is idle and it's not holding the same lock that would cause it to change value, the moment after it checked, that is idle could change.
Well, it is holding the same lock that would prevent it. It's just the lock isn't in the rate limiter instances. It's in the generic rate limiter itself, because we own all of the instances of the non-generic ones. So we control access to it, thus like any state change.
The outer generic is doing the is idle state change on the inner rate limiter?
No, it's checking. It's not doing the state change.
Yeah, I think the reason why the outer one controls it because the outer one is the party that gets to call acquire, right? So it basically knows unless I call acquire, that property can't change.
But let's say my rate limiter was a time-based rate limiter. The moment
Like
the moment after I call is idle, which returned false, time moved forward, and it now would return true.
Right. So it would just be delayed in internal GC. Like, yeah, I think that this is that they're writing their own notion of a expired reference, and they want to be able to prune it out of the dictionary or other collection.
So the assumption we're making here, right, is if we can see that the rate limiter is idle, and we don't call acquire again subsequently because we have a lock and we won't, like that it's safe to GC it. So we're in a world where it's like token bucket concurrency limit, where if you don't call acquire, it doesn't suddenly become unidle, or it
Okay, so
doesn't suddenly become
the assumption
wrong
here is, to restate that, the assumption is the only way you can go from is idle true to is idle false is by explicit usage of the rate limiters APIs.
right.
Yes.
Because like if there was some external state recreating, like say like it's like the Azure throttling thing, right? Like it ends up kind of being a moot point. It's like an efficiency thing, because like if you're getting external state when you recreate the rate limiter, fine. Like it's always could be
But
idle
that
'cause
also
you're,
means
like,
for
replenishing the state.
that means that that might be a fine answer, but it does it means I can't write a rate limiter that is simply monitoring something else.
It can never be idle at that point.
Right.
Or if it was monitoring something else, it means when you recreate it, it has to like remonitor. At that point, right? Like
no, I think your first answer was right. I think it can never return true from is idle.
If it has any like internal state like that would cause it to be different when it's recreated.
Like if you were bizarrely making a rate limiter that was universal and it's asking Azure Table Storage for things, like it can't ever know if it's idle.
It will always
It could say it's always idle. It'd be inefficient, right? Because then it would just be requiring table storage every time it's recreated.
Well, if it didn't itself maintain any state.
Right, exactly.
If it also maintains state based on some externality, then that instance is relevant, and so cleaning it up while someone else might be using it is a problem.
So yeah, if you're a rate limiter that has internal state that's like relevant and can't be like recreated by just like reconstructing it from the delegate or whatever, then yes, you can never be idle.
Okay, okay. As long as the assumptions are very clearly stated about what it means.
Is there a reason the idle sense is abstract?
Yes, I think that would force all implementations to have to implement this. So we could have a presumably accurate view of if they're idle or not. Whereas if we like provided our own thing, it'd just always be null, and people could just choose not to implement this and have essentially a memory leak. But if they have their own custom.
Certainly the easiest implementation, and one that tells you that one that makes you not have bugs other than an idle partition keeps its rate limiter around forever.
Right.
Can I just I just want to double check my understanding of something again, because I'm confused by something you just said. The generic rate limiter only ever constructs rate limiters that it itself knows about, right? A generic rate limiter will only construct rate limiters written by Brennan and Stefan, not by me.
No, with the middle in the example,
yeah.
Assuming the current shape with policy looks like it's give me any limiter you want.
Yep.
Oh, I didn't see the difference between limiter options and limiter.
Yeah.
Yeah. So and if we did like the delegate one that you're proposing, like they could return their own instances that they construct. So yeah, we have no limit on what implementations you use.
I see.
Anyway, it just seems like, so I don't know, like it shows right now there's an is idle, which is a get only bool, which means that the logic must come from somewhere else. And it seems like whatever lets that get set, that can just update the property. And then if it sets it from true back to false, then it nulls out the property. Like this feels like the base class can 100% handle this. And if you need it to be virtual because somebody maybe has a weird other way of doing it, like if there's an obvious implementation the base class can handle, why is it abstract? Oh, those are alternatives, not existing
Yes.
I assume.
Oh,
that
I
you
see.
said that
Okay,
those
now
were
your
existing.
statement makes sense. It's like what?
Yes.
What?
Fair enough. It's still a little weird because I imagine every implementation is just going to say return _ idle sense. But the way that they have to know that they need to build that field is, would of course be non-obvious.
Right. You could alternatively query if something is idle with a method. Kind of like how we have the query for permit count. The get permit count, I think, is the API. So you could have is like get is idle, get idle state, get.
Do we already make, I mean, in your prototype, do we already make use of the date time value? Like we use that to prioritize which ones we call or something?
Not yet. Because that would have required adding this API to runtime and then compiling all that stuff. And I was using a different repo. But yes, the idea was that we would not just immediately call it, like give it some amount of leeway.
Just double checking we're actually planning to use it, because otherwise it's an unnecessary expense on the implementer.
Well, because if we didn't have it, we just grow the internal dictionary indefinitely with rate limiter, idle rate limiters.
No. I'm not talking about a Boolean idle. I'm talking about how long have you been idle?
Date time, yes. Yeah, I mean, yeah, my idea was that we wouldn't just immediately do it if it was idle. We would wait a little bit because, yeah, it makes more sense, I think.
I mean, I slightly wonder if it's that we want, instead of this returned property, unless we think it's the right answer, that it's really more you want on rate limiter. You kind of want something like bool dispose if idle that tells you whether or not it disposed itself, and you just walk over all the things and call dispose if idle on them, and n of them will tell you, oh, I was idle, so I disposed myself, and you pull them out of the tree. The only reason that the date time really makes sense is if you think that there are going to be situations where somebody wants to vary the cleanup policy of don't clean things up unless they've been idle for 10 minutes versus don't clean things up unless they've been idle for 10 seconds. And if you think that that is really going to happen with things of whether it be the, let's call this the partitioning rate limiter, or somebody writing a similar thing on their own, again, then it makes sense. But if it's really just down to we need this Boolean, and if we've evaluated this condition, we need to call dispose. Also, we need to be aware for our dictionary removal that happened. Like that's really just dispose if idle. Now the type defines its own version of idle. If it has no notion of idle, it always returns false. And dispose if idle is super easy.
And their dispose if idle could delay it by 10 minutes if they wanted.
Right, they could have the internal notion of like they return, last activity question mark whatever, like that they know what their notion of idle is, and the only statement is if you're idle, dispose yourself and tell me you did that. And
yeah,
but again, if we think that there's complicated user policy built on top, this object gains a timeout policy later, then the date time is the more flexible solution. It's just if we never use it for anything more than if idle since is not null and is older than more than 5 seconds ago, then call dispose, then it feels like we added a lot of value-based structure to a thing that was just a Boolean.
Right.
It would also seems odd to have the datetime baked into it, because that would now basically mean that the how long something has to be idle before it's disposed is effectively global for all the rate limiters, right? When I think what Jeremy just suggested is if you just say, well, the rate limiters only know when they're idle, they could have different policies. One can say, I consider myself idle if I haven't seen anything in the last 20 minutes, and the other could say, I haven't seen anything in the last 5 seconds, right? It would also depend on what kind of limiter are you, right?
Like in Azure one, that query storage might be like 10 minutes is a good idle time because I don't want to be recreating this every few seconds if you dispose it.
Which is also why exposing the datetime seems odd, because it would suggest that there is a global policy.
Right.
Another thing is, even if for the generic rate limiter we did have an option to call after 10 seconds or 10 minutes, like presumably there's a scan, right? So we could track like how many scans in a row the thing has been idle or whatever, and guess if we really wanted to. Like it's possible that it's become idle and unidle and idle again, but if it's anyway.
True,
but yeah, I'm not sure. Like I could conceivably see like not wanting to like recreate rate limiters too often, and want to have a larger idle timeout, but I don't know how important scenario that is.
Again, so if the date time is returned and you're writing your own table storage based provider, you can simply always choose to, okay, hey, I've hit my neutral state. Great, set idle since to now plus 20 minutes. Like, I'm automatically asserting 20 minutes of activity after the last activity. Don't free me too eagerly. So it is doable. But like I said, the notion of exposing the date time is fine if we believe that there will be some notion of dynamic policy. If the only envisioned usage of it is you have this scan loop that says do date time dot now subtract or add minutes -5, now walk over everything, then that's really just dispose if idle, and let the rate limiter decide what idle actually means.
So out of curiosity, when storing what's basically like a local time, or representing it, do we typically use datetime and not datetime offset?
I believe the answer is all API should use datetime offset unless it has a really good reason why it can't.
I mean, I guess in this case, if the assumption is that this is all processed local, I think it's probably fine. The problem with datetime offset is the problem with datetime is that you don't know the offset, so that's really more annoying when you go across machine bound. You stay within the same process. For all we care, it could be a time span, right? Realistically, right? It could be like, for how long have you been idle, right? There really is no notion of it.
An added benefit of the dispose if idle thing is that you don't need, well, the lock is internal to the implementation of the rate limiter now. So you don't have to rely on some global lock that we're doing for the generic case where we own the entire end to end.
It is a bit weird though to have an object that self-destructs.
Right. Because if there are multiple users, who knows that the other person called like dispose if like are they then they have to synchronize anyway.
Well, but that's I mean, it's a two-state thing, right? It's check if you're idle, and if so, dispose. But that's like if you look at all the concurrent collections, that's how they're all modeled. It's I need like add this thing and tell me if you did that, or remove this thing, but tell me if you did that, or add this thing and if it's there, then run this other func and I'll do that under a lock and everything will be totally fine. Because once
essentially a ref handle,
you have to do like I need you to atomically or effectively atomically dispose, but only if you're idle. And
I I agree with that in principle, but for dispose, like if you're not synchronized with the other callers and you may or may not dispose, like OMG, you're just going to get ODEs on the other threads. Which I mean, maybe that's okay.
Yeah,
like,
I
I
mean,
just feel like you have to be synchronized anyway for dispose. But yeah.
yeah, I mean, again, the time span is, or the not time span, the point in time of when did I last go into a state where I was effectively freshly constructed is, it's reasonable. It's just, it feels a little weird.
But to go back to concurrent collection, right? It's not atomic, right? Concurrent collections usually expose something like is completed and then, right? So normally you would have a while not completed and then you have a using around. Yeah, the assumption is generally speaking that completed. There might be a race condition the way it's constructed. You race condition. There's no dispose when done. Atomic operation.
That's fair.
And that would be, I guess, the same thing here, except it's not really. Just the assumption we stated earlier, right? Like, unless somebody calls fire, or once you set your idle, you idle.
Yeah, as far as date time versus date time offset, the guideline, use date time offset when you're referring to an exact point in time. For example, now, a transaction time, a file change time, a logging event time, etc. And since I think you would conceivably log this, it should be date time offset. Date time is basically for you wanted date only, or you need to float the notion of someone wrote this time and didn't tell me what time zone it was in, so let's play the fun date time kind unspecified game of this means whatever you want it to mean.
I mean, in my view, it's like whether this property returns date time or time span is basically irrelevant, right? That kind of tells me that also using date time and date time offset really makes no difference.
Well,
well, if it returns a
makes
date
sense.
time with an unknown kind, then now you can't do math.
Yes.
Date time offset actually guarantees a time span, and date time produces an answer. So,
yes, that's fair. I guess daytime offset would have the benefit that you really don't have to care how people acquire the daytime.
right.
All right, so I think we've hit the end of this part of the discussion. It feels like not daytime if we want to do this. We had a few possibilities. Like it was, I think the leading ones are this with date time offset or time span.
How would time span work?
I mean, with time span, basically, again, every implementation would be return, date time offset .utc now minus the instance of the time that I went back into the default position, because that's the only thing you can really prove is what time did you do something, or that you can assert is what time did you do something. Now, granted, actually, no, you could, if you actually really cared and you really wanted it to be correct, then you would build the time span property based on a stopwatch that you created when you did the thing, so that NTP didn't adjust your values. Yep. Because returning a date time of when you were idle is subject to NTP errors.
So then idle since would have to recalculate itself every time it was accessed.
If it's a time span, there would be math every time, yeah.
Yep.
Yeah, I don't see that as being like super expensive though. Like getting a time span, like comparisons of date times, are like similar.
And again, I mean, that's what the callers only are going to use it for, right? They're going to, I guess, build a point in time or build a time span, and then just do greater than or less than, and move on. So the math is going to be done either way. It's just a question, I guess, of what you want the log to say. Has been idle for 15 minutes and 7 seconds, releasing it, or has been idle since the timestamp, releasing it.
And then if it was a time span, it would be like idle for instead of idle since.
Yeah.
Yeah. I mean, I kind of like it. I don't have a strong.
I like the log better.
With a time or with a time span?
Time span.
Just saying it's been idle for 15 minutes, getting rid of it?
Yeah. That sounds way better than idle since, because that you can lose the time of the log and everything, or just not log time, which a lot of people don't do.
Yeah, this seems to be like not a thing where somebody actually cares about the time, right? You really just care about for how long was it.
Yeah.
Right. The other reason why stopwatch is probably the better choice is also depends on like how aggressive you want to be. Like if you only care about minutes, it probably doesn't matter. But if you talk about seconds or milliseconds, then daytime comparisons will probably not be great.
I mean, they go down to the tech. It's just the question of, did you have a clock adjustment in the meantime?
Yeah, there's that too. But I mean, I was thinking like even ticks and windows are not like that accurate.
That's true. The stopwatch has
it uses the high frequency thingies in Windows. I don't know what it does in Windows.
Probably just calls get current time and saves it to the second.
Yeah.
There's a high precision clock in Linux. It probably uses that.